Alright, today we're going to continue with factoring, and the goal for today is to factor polynomials with a leading coefficient other than positive 1. Now, before we get into how to do that, let's just review here. This is the form that all quadratic trinomials are written in. This is something that we're going to get very familiar with in the coming weeks. And it says that quadratic polynomials can always be written in the following form: ax squared plus bx plus c. Now, we know that these terms can be both positive and negative. Doesn't have to necessarily be an x, but we always see this format here, and where a, b, and c are always integers. And then we have a variable that has an exponent of 2, a variable with an exponent of 1, and then we have a constant term sitting out here, just meaning that there is no variable. But this right here is sort of the universal format that we'll be using to factor. Now, yesterday we learned how to factor with a leading coefficient of 1. In other words, that's when our term a is equal to positive 1. For example, n squared minus 4n minus 12. And we learned that the trick to factoring this is to think of factors of c, right? Because c is our third term. So factors of c, or in this case negative 12, that have a sum of b. So in other words, factors of negative 12 that have a sum of negative 4. Now, when c is negative, sometimes it's helpful to, list some factors here. Okay, what are some factors of negative 12, right? Well, we got, negative 3 and 4. We got negative 4 and 3. But neither of these have a sum of negative 4. I have 6 and negative 2, and then I have negative 6 and positive 2. Now, it looks to me like this fourth one I listed here, negative 6 and 2 is going to work because negative 6 times 2 is negative 12. That gives us C. Negative 6 plus 2 is negative 4. That gives us B. So this polynomial, rather, in factored form is n minus 6 times n plus 2. And you could go ahead and multiply those binomials if you wanted just to test it, and it would give you the exact same trinomial that we see here at the top. Now, for today, we're still going to keep this pretty simple. Factoring can get pretty complicated whenever the leading coefficient is something other than 1. So whenever you're asked to factor, that's like the first box you need to check off is always, okay, what's the leading coefficient? Because if the leading coefficient is positive 1, well then we just go right back to what we did yesterday. That becomes a much simpler problem, a much simpler process. Starting today, though, we're going to see something like this, where it's 2y squared plus 10y minus 12. And I can't follow the same method that we used, where we just find factors of c that have a sum of b. The reason for that is because of this right here. This positive 2, this leading coefficient, prevents us from being able to use that. That method is only applicable when the leading coefficient is 1. Now, for today, to keep things a little bit simple, we're going to make it so that the leading coefficient can be factored out of the problem. So this is also the second box you want to check, right? So box 1 is, okay, what's the leading coefficient? Oh, crud, it's not a positive 1, it's a positive 2. Okay, well, here's the second box you need to check, and this is what we're going to be doing today. The second box to check is, can I factor out this leading coefficient? And in all of our examples today, the answer to that is going to be yes, yes we can. And the way we do that is I look at my three terms here. I look at my A term, my B term, and my C term. And I ask myself, okay, is there a common factor here? Do 2, 10, and negative 12 all have a common factor? Remember, we're always looking for positive factors whenever we do this. And you'll see pretty quickly that they're all even numbers, 2, 10, and negative 12. So I can factor out a positive 2. So just like it says here, step A, factor out the leading coefficient. So I'm going to write a 2. In other words, we're taking this whole thing and dividing it by 2. So 2y squared divided by 2, 10y divided by 2, negative 12 divided by 2. And when I do that, here's what I'm left with. Okay, the 2 cancels out there, so that just leaves me with the y squared. 10y divided by 2. Well, 10 cancels with the 2 to give me positive 5, so plus 5. Y comes along for the ride. We haven't canceled out any y's. And then finally, we just have negative 12 divided by 2, which is negative 6. Okay, so already we've factored this somewhat. We've renamed this trinomial as a product of positive 2 and this trinomial here, y squared plus 5y minus 6. Now step B is to factor what remains, if you can. You won't always be able to. Sometimes we get to this and we look at what's here, we say, hey, we can't factor it. There's nothing else that can be done. In this example, we can though. So we're still leaving this 2 out here, but you can ignore it for now. This trinomial inside the parentheses has a leading coefficient of 1. Oh, that's perfect, right? Because now this is really easy to factor. Now I just have to ask myself, okay, factors of negative 6 that have a sum of positive 5. So you can think about that on your own for a second. You can list a few factors of negative 6 that have a sum of positive 5. Well, I think in this example, that's just going to leave us with, I think the answer is going to be positive 6 and negative 1, I think, right? Because 6 times negative 1 gives us negative 6. 6 plus negative 1 is positive 5. So we're going to rename this trinomial as y plus 6 and y minus 1. And there you have it. There is our completely factored answer. This is what you want to get right here. We're taking this trinomial, this messy looking trinomial. We started by dividing out the leading coefficient. That got us the 2. And then we factored from there. So our factored answer is 2 times y plus 6 times y minus 1. More practice with this coming today. Again, all going to be examples similar to this where we're factoring out leading coefficients and then factoring what remains as much as we can.